This is example number 5, chapter quadrilateral. The question says that show that the bisectors of the angles of a parallelogram form a rectangle. That is the interior angle bisectors. So first we need to take a parallelogram. Let's say I've taken a parallelogram and say if I name it as ABCD. And I'm going to draw the bisectors of these interior angle. Let's say this being the bisectors of the interior angle A. This is for B. Likewise, we'll make the bisector. Make sure when you're making the bisector, it should form a quadrilateral. And that's why I'm making like this. And finally, the bisector of the exterior angle. The next I'm going to make is for C. Let's say. And I name this figure as PQRS. Now, what we need to prove here that this figure, say PQRS, we have to prove this figure a rectangle. Now, what else you should know that in order to prove any quadrilateral or rectangle, we can do it in one way called by proving each angle of this quadrilateral as 90. Say this being 90. If I prove all angles as 90 degree, it becomes a rectangle. And that is what we are going to prove. Further, what we know that here, these two angles are equal because they are AR is the bisector. Likewise, here this angle say 3 will be equal to angle 4. And same here, that is angle 5 is equal to angle 6. They will be equal. Now, the property which we'll be using here is that interior angles on the same side of the transversal are supplementary, right? That means here angle A plus angle B will be a 180 degree. As you know that this and these are interior angles on the same side of the transversal, reason being these two lines are parallel. And likewise, I can say that angle A plus angle D will be 180 degree for the same reason as these two lines are parallel and this is the transversal. So interior angles on the same side of the transversal are supplementary. Now let's proceed with the working. What you will do here, first we will consider, say, angle A plus angle B. So we have angle A plus angle B is equal to 180 degree. And the reason is this, interior angles on the same side of the transversal. Further, as I can see that angle 1 and angle 2 are equal, and this is half of angle A. So I can replace angle A as twice of angle 1. And likewise, I can replace angle B as twice of angle 5 is equal to 180 degree. Now, question arises, why not I have taken twice angle 2 or twice angle 6? Because I'm going to target this angle and I'm looking for this angle to prove 90 degree. That's why I've taken angles which comprises of this triangle. So I can take 2 common now. So if I take 2 common, we'll get angle 1 plus angle 5 is equal to 180 degree. Transposing 2 to the other side, we'll write angle 1 plus angle 5 is equal to 180 over 2, that is 90 degree. Now, once we have proved this angle as 90 degrees, sum of these two, what we are going to prove? We are going to consider this triangle now. We will consider this triangle. We are considering this triangle. And since the sum of two angles, that is this plus this is 90, this angle, third will also be 90 by angle sum property. Right. So we'll now consider the triangle here, and the triangle considered here will be in triangle. This is A, R, B. We have this three angles here, angle 1 plus angle 5 plus angle R is equal to 180 degree, and that is from angle sum property. Now further, as you can see here, the sum of 1 plus 5 is given as 90 degrees. So I can replace this 1 plus 5, this angle, I can replace this 1 plus 5 with 90 degree. So if I write 90 over here, if I write 90 over here, so 90 plus R is equal to 180 degree. That means angle R will be equal to 180 minus 90, that is 90. So what we got? We at least proved one angle as 90 degree. We have proved one of this angle as 90 degree. Now, if you have proved one angle as 90 degree, we don't have to write down. Don't have to prove the other angle as 90 degree. That means if once this is proved 90, we can write directly this as 90 degree by similarly. So I'll be writing similarly. Similarly, you can write angle P is equal to 90 degree. Right, but we cannot write similarly S is 90 degree. For that, we need to prove this angle. So first I'll take angle A plus angle D as 180 degree for the same reason, that is interior angles on the same side of the transversal. This time, this AB and CD are parallel and this AD is acting as a transversal. So now I can replace angle A with twice of angle 2 and replace angle D with twice of angle 3 is equal to 180 degree. I can take 2 common and write angle 2 plus angle 3 is equal to 180 degree. And on transposing 2 to the other side, we'll get this as 90 degree. Now, once we have proved this angle as 90 degree, now we'll again be considering a triangle and we'll be applying angle sum property here. So let's say a triangle considered this time will be in triangle. This is AS. This is triangle ASD. Now, let's see what triangle I'm talking about. I'm talking about this triangle ASD. Here also, sum of three angles of a triangle is 180 degree. So therefore, I'll be writing angle 2 plus angle 3 plus angle ASD is equal to 180 degree. Now, as you can see here, we have angle 2 plus angle 3 as 90 degree. So we can replace this 2 plus 3 with 90, same as the done previously. So if I write this being 90 degree, so this plus angle ASD is equal to 180 degree. So on transposing, we will get angle ASD is equal to 90 degree. Now check here. We have proved one more angle as 90 degree. We have proved one more angle here as 90 degree. And this time, the angle taken is ASD. Now, on proving this ASD as 90 degree, on proving this angle ASD as 90 degree, we can similarly write, after proving this as 90 degree, we can similarly write this angle as 90 degree. That is, we're writing similarly. Similarly, the name of this angle is, besides that, we have proved ASD as 90, right? Right, we have proved ASD as 90. So we have to prove the interior angles, right? So we cannot go by that. We have to write this angle as 90 degrees. So we'll be writing angle PSR is equal to, as you know, vertically opposite angles are 90. So this I need to mention as 90 degree. Now you should understand what I am saying here, that vertically opposite angles are equal. And that's why I wrote this angle also as 90 degree. This angle as 90 degree, reason being its vertically opposite angle is 90 degree. Now, therefore, we will be writing similarly. Similarly, we can write this angle as the other, that is PQ, the fourth angle, PQR is equal to 90 degree. Now check here, we have proved 4 angles as 90 degree. So this is, you can see one here, the other here, third here, and this fourth here. So we can write what? Angle P is equal to angle R, which is equal to angle PSR, and that is equal to angle PQS. And they are all equal to 90 degree. Therefore, PQRS is a rectangle. So this is how this question can be done by proving all 4 angles as 90